Welcome! 8 advanced JavaScript interview questions for senior roles. That's right. Yesterday I failed basic role questions, so maybe I'm just a senior developer, Maybe that's why I don't know the answers for the easier questions. But let's find out together. Oh my god, this article is long. Doesn't matter. Let's do this. JavaScript is a powerful language that is some of the primary building blocks of the web. This powerful language also has some of its quirks. For example, did you know that 0 triple equals minus 0 evaluates to true? Or that number, nothing, yields 0. Okay, I didn't know this. So maybe I'm not a senior developer either. The thing is, sometimes this... Okay, let's go. In this blog post, we will see an in-depth explanation of some important JavaScript interview questions. My goal will be to explain these interview questions thoroughly so that we can understand the underlying concepts and hopefully solve other similar questions in interviews. Very good. First, a closer look at the plus and minus operators. Oh my god. Console log. 1 plus 1 in quotes minus 1. Actually, I think I know the answer to this one. Not because I've seen it before, but I did some type coercion stuff in JavaScript and I'm not gonna scroll to the answer. But let me try. I will show you how to do this. So you need to divide this into 2 sections or maybe more. So first let's take a look at this. We always go from the left. So here we have, oh my god, this is so bad. So here we have a number plus a string. When you are using a plus operator, JavaScript for some reason prefers strings. If you try to add something to a string, it will automatically convert it to a string. So a number 1 plus 1 is going to be a string that equals to 1, 1 as a string. Don't forget, this is a string because it converted both of the sides to string. And then we're gonna subtract 1 from that. So with the subtraction, it's different because with subtraction, you can't subtract from a string. So what's JavaScript gonna do? It's just gonna convert it back to a number. So in this case, it converts it back to 11. So this is equals, not really equals, but okay, so this is going to be 11 minus 1, which is 10 as a number. Not in quotes, not as a string. It's 10 as a number. I think this is the solution. Well, let's see. How can I clear this? So here we go. Can you guess the behavior? Okay, when JavaScript encounters 1 plus 1 in quotes, it processes the expression using the plus operator. One interesting property of the plus operator is that it prefers string. See? That's what I said. Maybe I'm indeed a senior developer, maybe. The string concatenation one of the operands is a string. In our case, 1 in quotes is a string, so JavaScript implicitly coerces the numeric value of 1 into a string. Consequently, 1 plus 1 in quotes becomes 1 in quotes plus 1 in quotes, resulting in the string 11 in quotes. Now, our equation is 11 quotes minus 1. The behavior of the minus operator is quite the opposite. It prioritizes numeric subtraction, regardless of the types of the operands. When the operands are not of the number type, JavaScript performs implicit coercion to convert them into numbers. In this case, 11 is converted to the numeric value 11 and the expression simplifies to 11 minus 1. So it's 10. Yeah, baby! Senior developer. That's right. I'm a senior developer. Next one. Let's do this. I'm gonna roll this through 100%. Duplicating array elements. Consider the following JavaScript code and try to find an issue in this code. So we go through the array, right? To the end of the array, we put all the, so we duplicate, not like make a copy of the array, we just duplicate all the elements. So they twice in the array. So it becomes like 1, 2, 3, and then 1, 2, 3 again. Okay, I understand. Now, what's happening? Let's check. So this is the array, this is duplicate. I think this looks to be fine. Although, yeah, this is fine. Array.length, is this not a keyword? No, it's fine. And I++ array.push. I think I know the answer. I think I actually know the answer. And the problem is that if you keep adding stuff to the array, then this I is never, this is going to be an infinite loop because it keeps growing. And with the for loop, it doesn't make a duplication of the array dupe, but you do the operation on the actual array. So this should be the initial length should be somehow stored and done with that, because this array length is going to be increasing. So this never ends. Huh? What do you think? I think that's the solution. In this code snippet, we are required to create a new array containing duplicated elements of the input array. Upon initial inspection, the code appears to create a new array by duplicating each element from the original array. However, a critical issue arises within the duplicates function itself. Okay, so far so good. The duplicate function uses a loop to go through each item in the given array, but inside the loop, it is adding a new element at the end of the array using push method, which makes the array longer each time. Yes, creating a problem where the loop never stops. The loop condition I is smaller than array length always stays true because the array keeps getting bigger. Woo! 2 out of 2. To address the problem for an infinite loop caused by the growing array length, you can store the initial length. Senior developer. There you go. Okay, so we store it before the loop, then you can use this initial length as the limit for the loop iteration. This way the loop will only run for the original elements in the array and won't be affected by the array's growth due to duplicates. Okay, so this is the solution. See, she stores the initial length and uses that. Here, where's the pen? Here you go. So it does that and then that here. No, so the array length is, we store it. So the output will show the duplicated elements. Okay, so fine. Difference between prototype and proto. We are getting into dangerous territory. The prototype property is an attribute associated with the constructor functions in JavaScript. Constructor functions are used to create objects, yes. So when you define a constructor function, you can also attach properties and methods to its prototype property, yes. These properties and methods can then become accessible to all instances of objects created from that constructor. Thus, the prototype property serves as a common repository for methods and properties that are shared among instances. Okay, so we have considered this snippet. Okay, we have this snippet. We have a person, yeah. Adding methods, so we do person prototype say hello, and it prints out the name. Okay, so that this, and in the constructor this.name is name. Person 1, okay. Person 2, okay. Hello, my name is Omar. Okay. So what's the question? In this example, we have a constructor function named person. By extending the person prototype with a method like sayHello, we are adding this method to the prototype chain of person's instances. Yes, this allows each instance of person to access and utilize the shared method, instead of each instance having its own copy of the method. On the other hand, the proto property, often pronounced as the $proto, exists in every JavaScript object. Yes, in JavaScript, everything except primitive types can be treated as an object. Each of these objects has a prototype which serves as reference to another object. The proto property is simply reference to its prototype object. The prototype object is used to fallback source for properties and methods when the original object doesn't possess them. By default, when you create an object, its prototype is set to object prototype. Okay? So when you access property and method on an object, JavaScript follows a lookup process to find it. This process involves two main steps. Objects on properties, JavaScript first checks if the object itself directly possesses the desired property. So what? I don't understand. Is this code bad or what? Can I run it? No, it's okay. We make a new person. So what's the question? If the property is not found, even the object prototype, JavaScript returns undefined, indicating. So what was the question? Oh, the question is what's the difference? Oh, well. It was kind of answered, so we can just skip this. Okay, this is gonna be skipped. This is like it's just a learning moment. Okay, so it doesn't count. I have still what 2 out of 2. So the next one, scopes. As you remember from yesterday's video, I'm the master at scopes, so this is gonna be easy. When writing JavaScript code, it's important to understand the concept of a scope. Scope refers to an accessibility visibility variable. Okay, don't care. Let's take a closer look at the snippet. Okay, we have a function foo. which logs a, okay, function bar. It has a variable a equals 3, then calls foo. And then we also have a variable on the global scope, which is 5, and then we call bar. Oh, I already know what the question is, and I'm just gonna scroll back because I don't want to read the answer accidentally. What's happening here is that we call the bar, and in the bar we set the a to 3, and then we call the foo, and then we log the a. And the question is it 3 or is it 5? I will tell you, because I know the answer. Yeah, I think I know the answer. It's gonna be 5. It's gonna be 5 because the foo function was defined in the global scope, and therefore this a is going to refer to this there. This doesn't matter, okay? So the code defines two functions, foo and bar, and variable, okay, we already know. All these declarations happen in the global scope, see? Inside the bar function, a variable a is declared and assigned a value 3. So when the bar function is called, what value a do you think you will print? When the JavaScript engine executes its code, the global variable a is declared and assigned the value 5. Then the bar function is called. Inside the bar function, a local variable a is declared and assigned a value of 3. This local variable a is distinct from the global variable a. After that, the foo function is called from within the bar function. Inside the foo function, the console log a statement tries to log the value of a. Since there is no local variable a defined within the foo function scope, JavaScript looks up the scope chain to find the nearest variable named a. The scope chain refers to all the different scopes that a function has access to when it's trying to find a use variable. Now, let's address the question of where JavaScript will search for the variable a. Will it look within the scope of the bar function, or will it explore the global scope? As it turns out, JavaScript will search in the global scope. Yes! And this behavior is driven by a concept called lexical scope. See, I knew that. I knew that phrase, lexical scope, definitely not hearing it the first time. Lexical scope refers to the scope of a function or variable. And listen, okay, you don't know. I already know you don't know. At the time it was written in the code. When we defined the foo function, it was given access to both of its own local scope and the global scope. These characteristics remain consistent no matter where we call the foo function, whether it's inside the bar function or if we export it to another module and run it there. Lexical scope is not determined where we call the function. Okay, so it's where you defined it. The upshot of this is that the output will always be the same, the value of a found in the global scope, which is in this case is 5. However, if we had defined the foo function within the bar function, a different scenario emerges. So if it's within the bar function, then its next scope upwards is the bar, and therefore it should be, I think, 3, right? Surely, because this comes. Oh my, what's this? So this comes after this, see? Because we're in the bar function scope, where the definition is of the foo. So now foo, this will look into upwards into the next scope, into the parent scope, which is bar, so it's gonna be 3. In this situation, the lexical scope foo will encompass 3 distinct scopes: its own local scope, the scope of the bar function, and the global scope. Lexical scope is determined by where you place your code in the structured code during compile time. When this code runs, foo is situated within the bar function. This arrangement alters the scope dynamics. Now, when foo attempts to access the variable a, it will first search within its own local scope. Since it doesn't find a there, it will broaden its search to the scope of the bar function, so it goes up. Lo and behold, a exists in there, so it's 3. Very nice, very good. Okay, next one. I don't want to scroll down to find the answer. Okay, so we have object coercion. Oh boy, this is gonna be awesome. We have a constant named object, and value of method returns 42 and the toString method returns 27. And we console log obj plus this. Okay. I know the answer to this one too. Oh my god. Or at least I think I do. So what happens here is when you try to access an object, like to print or to convert to a string, like you automatically think that the toString method is called, which is not true, because first the value of method is called? So this is a tricky question. And for that, this is going to be, the answer is going to be 42, like this, as a string, I think. And I'm very, very convinced that's the answer. So, one intriguing facet to explore is how JavaScript handles conversions of objects into primitive values such as strings, numbers, or booleans. This is an interesting question that tests whether you know how coercion works with objects. This conversion is crucial when working with objects in scenarios like string concatenation and arithmetic operators. To achieve this, JavaScript relies on two special methods, value of and toString. The value of method is a fundamental part of JavaScript object conversion mechanism. When an object is used in a context that requires a primitive value, JavaScript first looks for the value of. Yes! Yes! In cases where the value of method is either absent or it doesn't return an appropriate primitive value, JavaScript falls back to the toString method. Yeah, baby, I think I got this one too. Oh my god, 100% speedrun. Okay, this method is responsible for providing a string representation of the returning to our original code snippet. Okay, so when we run this code, the object is converted to primitive value. In this case, the value of method returns 42, which is then implicitly converted to a string due to concatenation with an empty string. Consequently, the output of the code will be 42. However, in cases where the value method is either absent or doesn't return an appropriate primitive value, JavaScript falls back to the toString method. Lets you modify previous example. So this, in this case, is going to be 27. I'm a senior. I'm a senior. I think that explains everything. So let's go to the next one. I mean, this is gonna easy peasy from here, right? Understanding object keys. When working with objects in JavaScript, it's important to grasp how keys are treated and assigned with the context of other objects. Consider the following code snippet and take some time to guess the output. Okay, so breathe in. Let's breathe in and let's just let's go, baby. So we have A, an empty object, B, which has key test, and C, key test. Okay, so and then we set A. What's this? We set A, B, 1, 2, 3, and AC. Okay. Let's take a second. So we try to do this, right? So the question is, what's gonna happen? What's gonna be B here? And you might think it's gonna be something from here, but I think type coercion is going to happen here. So he's going to try to somehow, like JavaScript is going to try to somehow like convert this into a string or something, or like something like that. Yeah, and that should return the same for B and same for C. Something like something like in this and like object or object or whatever, and in these brackets, you know, when you do this, and when you make it to a thing. I think that's the answer. So these are the same keys. B and C are the same keys, so it's going to be 4, 5, 6. He's going to have a key of this object which equals to 4, 5, 6. So there's only one key. Oh my god, I'm so nervous. I don't know. Maybe that. So let's see. At first glance, it might seem like this code should produce an object A with two distinct key value pairs. Oh my god, I think I guessed it right again. However, its outcome is quite different to JavaScript's handling of object keys. JavaScript employs the default toString method to convert object keys into strings, but why? In JavaScript, object keys are always strings or symbols, or they're automatically converted to strings via implicit coercion. When you use any value other than a string as a key in an object, JavaScript will internally convert that value to a string representation before using it as a key. Oh my god, consequently, when it uses B and C, both are transformed into the same string representation. Yeah, this is what I wrote. Oh my, I deleted that. Due to this behavior, the second assignment will override the first assignment. So let's break down the code step by step. We get an empty object and then create an object with a property key, and then the same with the C. This is going to be the key, so B is going to be this. And oh my god, updates all from the same property because it's the same key. Both assignments utilize identical keys string object. As a result, second assignment overrides the value set by the first assignment. Oh my god. When we log the object A, we observe the following output. Oh my god! I'm officially a senior developer. And I don't know. I hope this is the end. Are there... Oh, the double equals operator. Oh my god, what's this? I will need all my power. So the question is, what's gonna be printed, true or false? And it's definitely going to be tricky. So let's start with this operator. We always start with that. So not an array. What's that? So this operator does like convert it to a boolean based on if the value is like a falsy or truly or whatever. And I think that this is a falsy value because it's going to be an empty string if you run the toString function, right? Because it's basically an object, so the toString method is going to return an empty string. An empty string is a falsy value. So this is going to be true. Is this going to be true? Am I sure? I don't know. So it's either true or false. Okay, let's just skip that and we will return to that later. Okay, how can I clear this? So now we have either this equals like true or false, right? Let's say true. And then so somehow something must be done with these. And what JavaScript does, I think here, you will try to convert this into like some new, he's going to convert this into like maybe numbers. I think so. So this becomes 1, right? And what does this become? Well, I don't know. What's this? Is this a 1 or is this a 0? So the toString, if it goes into string, then it's going to be empty, and then it's going to be 0. But here we had a clue. In the beginning of the thing, there was this number thing. Let me go back. It's not cheating. Shut up. Did you know that it's 0? Okay. So I cleared everything, but this we said it's gonna be probably true, and this is now 0. And does 0 equal true? Well, no. That's not true. Am I correct? So this is now 0, this is now true. But then it's converted into true is converted into a number, and it's probably 1. Or is it 0? I don't know. Maybe true is converted into 0. Because he also wants to convert this side into a number, right? So converting boolean true into a number it doesn't necessarily mean it's going to be 1. It's like it's a number conversion, you know. And I think it's going to be 0, or I may be entirely incorrect. So then this is going to be 0 equals 0, which is true. Oh my god. Oh my god. I think this is true. Oh my god, I don't know. Is this okay? So this becomes boolean true at the first step. So we have true, and this stays an array, and then we convert them to numbers. So this toString method, it's an empty string, so this must be 0, right? This must be 0, and the question is what this becomes, and I think this becomes 0 too, and 0 is equals to 0, and this is then true. Oh, I think this is so bad. This is so incorrect. But I might be right. But I might be right. Okay. Deep breath. I'm gonna reveal the answer. I don't think I'm gonna like it. Okay, so this one becomes, so what do you think will be the output? Let's evaluate the step by step. Let's first start by seeing the types of both operands. So this is an object, this is a boolean, right? Okay. For this, it's an object, which is understandable. Everything in JavaScript is an object, including arrays and functions. Okay, but why does the operand has a type of boolean? Okay, so the exclamation mark. Okay, let's try to understand. When I use the exclamation mark with a primitive value, the following conversion happen. Okay. Falsy values. The original value is a falsy value, such as false, 0, null. Oh no. or empty string applying will convert it into truthy values. If the original value is a truthy value, any value that is, oh no, oh no, oh no, oh no. So this is false. So this is false in our case. Brackets empty value array, which is a truthy value in JavaScript. Oh my god, it's truthy. Oh my god, it's truthy. Since brackets truthy, it becomes false. So I was entirely incorrect. So expression becomes this equals false. Now let's move ahead and understand the double equals operator. Whenever two values are compared using double equals, JavaScript performs the abstract equality comparison algorithm. Okay, the algorithm has the following steps. Okay, I just memorized this, okay? Just pause the video and do that too. Okay, as you can see, this algorithm takes into account the types of the compared values and performs necessary conversions. For our case, let's denote x as the array and y as the what. We inspected both types x and y and found x is an object and y is a boolean. Since y is a boolean, x is an object, condition 7 from the abstract equality comparison algorithm is applied. If type y is a boolean, return the result of the comparison to number y. Okay. I was kind of right, but I was just wrong about the falsy value so far. Okay, meaning if one of the types is a boolean, we need to convert it into a number before comparison. What's the value to number y? As we saw, array is a truthy value, negating makes it false. As a result, number false is 0. Oh! I was accidentally right. I thought that the number, oh my god, and number true was 0 in my case, but oh my god, true, I make two mistakes and it actually accidentally comes out right. Now we have the comparison. Array equals 0 and this time condition 8 comes to play. Okay, so type x is either a string or number and the type y is an object. Return the result of the comparison x to primitive. Okay, based on this condition, if one of the operands is an object, we must convert it into a primitive value. This is where the toPrimitive algorithm comes into the picture. We need to convert x. Okay, arrays and objects. Okay, we saw earlier that when converting object primitives, value of and toString methods. Okay, as a result, toString. Okay, empty array results in obtaining an empty string, which is a valid primitive. Okay, so now we have this. Okay, converting the empty array to a string gives us an empty string, and now we face the comparison like empty string is equal to 0. Now that one of the operands is of the type string and the other one is a number, yes, then it's gonna be converted. Yes, type x is a string, type y is a number, return the result of the comparison to number. Hence we need to convert the empty string to a number which gives us 0, and 0 equals 0. Oh my god, I actually nailed it. I made two mistakes, but they cancelled each other out. Here you go, senior developer. You can make two mistakes, you just have to make sure they cancel each other out. There you go, it's that simple. So I actually have it right. Oh my god, this is so dumb. Next, closures. This is one of the most famous interview questions asked related to closures. Okay, so we have an array, right? And we go through the array and we... I think I know this one too. So set timeout function, we log the index and the element value, but we have a delay, although I don't think that matters how much delay do you have here. So the question is what's gonna be on the console, and I'm gonna tell you what's gonna be on the console. All of the lines are going to be the same because I had issues with a similar setup, so I recall. See, we used var I here, and var is not a block variable, So what happens here is, as it sets this timeout function, this I value is going to be accessible outside this for loop, and each and every single time is going to be increased, and it's going to be increased up to 4, because when you exit the loop, it's gonna run this one less time, so it's not gonna be 0 to 3, it's gonna be 4. So you're gonna have index 4, and it's gonna be something like undefined, I think. like something like that, undefined. There you go. Am I a senior developer? Am I? So let's see. If you know the output, well, okay. What? Okay. But this is not the case. Okay, due to the concept of closures and how JavaScript handles variable scope, the actual output will be different. What's gonna be? Ooh. Well, yeah, you know, senior developer, you know. What can I say? Whew! When the setTimed callback is executed after a delay of 3000 milliseconds, they will all reference the same variable I, which will have the final value of 4 after the loop has been completed. As a result, the output of the code will be this. This behavior occurs because the var keyword does not have a block scope, and the setTimed callback captures the reference to the same I variable. When the callbacks execute, they all see the final value of I, which is 4, and try to access array 4, which is not defined. To achieve this desired output, you can use the let keyword. See, this is the same, you just change it to let. So with that, we get what you want. Using let creates a new binding for I each iteration, ensuring that the callback refers to the correct value. Often developers have become familiar with the solution involving the let keyword. Yes, this is how I knew this. However, interviewers can sometimes take a step further and challenge you to solve the problem without using let. Why? Why? It's dumb. In such cases, alternative approach involves creating closure and immediately invoking a function inside the loop. Okay, so you do this, where's the pen? So instead, you make this closure, okay? So where you immediately invoke this, you put the I here, and it becomes the index here. So now, this index variable is bound to this scope, so as you use it here and here, its value is not gonna change because it doesn't reference this I. They're no longer connected, sort of. No, this is like a new setup. So there you go. This solution is like before you had let, okay? But I wouldn't use this as dump. It's no longer holds value. In this code, the immediately invoke function index creates a new scope, yes, capturing the current value of I and passing the index parameter. This ensures that each callback function gets its own separate index value, preventing the closure-related issue and giving the expected output. Yes. Thank you for reading. I hope this post is helpful in your interview preparation journey, and if you have any further questions, don't hesitate to reach out. I'm always happy to help. Oh boy, easy. Sorry, easy. Turns out I'm not fit to be a junior developer. Unfortunately, I can only be a senior developer. Somehow I managed to get all the answers correct, even the one where I made 2 mistakes. But then again, who cares? The answer is correct. Ooh, this was rough. This was rough, but really fun. Thank you very much for watching the video. Leave a like. If you watched this far, I don't know, man, you gotta like the video. What do you want? Please like and subscribe. Subscribe so I can keep making stuff like this. It's really fun. I learned a lot. At least I learned how making 2 mistakes can lead to the desired output. Thank you very much for watching and see you in the next one. Goodbye.